Hey guys, it's Edbert. So today I'm going to react to some interviewing.io interviews from the perspective of both a coach and an interviewer. I'll go over what I think the interviewer himself is thinking, what the candidate could have done better, and what you can learn from all this. So here we have a Java interview with an Amazon engineer. It looks like there's some kind of sorted list problem, but I have not actually seen this interview myself. So I'll be giving you my raw, unfiltered reaction, and hopefully you guys actually learn something from all this.
I've been working as a backend engineer for the past 4 years, and before that I used to work as a full stack engineer. So right now I'm working for in the consumer space. So my work kind of entails working on the product side of things and also work on data infrastructure. So we are developing ETL solutions for enterprise customers. And I'm looking for jobs in the same area too. So I'm interviewing actively right now. So I have a few on-sites scheduled in the next couple of weeks. I had a few which I gave in the past couple of weeks. So it's somewhere in between. So I still have some more phone interviews which I'm going through right now. So I just wanted to see if I can have some more practice, having some peer-to-peer interviews.
So it looks like he has 4 years of engineering experience on the back end, and then a little bit before that as well. So I would say probably around 5 to 6 years of experience. So we can probably guess that this person is going to go for about an L4, L5 level. And based on what he said, it also sounds like he's not actually in that deep with the interview so far. He's still looking for practice before he really goes for the companies that he really wants to go for. So we can kind of expect that early on here, or at least for this particular interview, he's not going to be as sophisticated with a lot of these coding interview specific things. However, what I would expect is for him to show a good mastery of engineering, or at least the ability to weigh trade-offs and to be able to logically construct code or an idea to some degree, at the very least for the coding interview. So let's see how well he does.
Yeah, let me know if you already solved this problem or encountered similar thing.
Let me read it. When I see the...
Okay, so let's actually look at this problem. Given a list of daily temperatures, return a list such that for each day in the input tells you how many days you have to wait until a warmer temperature. If there's no future date, then just put 0. Okay. So in this particular example, you have 73, 74, 75, 71. And for the first the first number, you have 73. You just have to wait 1 day in order to get something warmer, which is 74. And then 74 has to wait 1 day, which is 75. And so the length of temperature will be 1 to 3,000, and the temperature will be an integer in the range of 3 to 100. I think based on what is being said here, I think the optimal approach to this, not necessarily the optimal solution, is to try and come up with the very bare basic naive solution, which would be just for every single index, just look ahead and solve for it individually, which would give you an n-squared solution. But I'm going to bet that there is a order n solution as well. Now what that is not immediately apparent to me. So let's actually see how he actually does this.
I think I've solved something similar, but I couldn't recollect it how I did it. But I have a sense of how I might have done it. We have temperatures which are, I'm assuming that these are all integers, so we are just considering integer inputs here, right?
Yes.
Okay. And then I think the range is from 1 to 30,000, so we are only considering so that's the length of the temperatures, and the temperatures are in the range of 30 to 100, so we don't have to worry about anything about the values. So yeah, I think the restrictions on the value and the length is pretty obvious. I'm thinking in this case, since we have to know not just since it's an array, so I have to first of all know how to iterate it, and also somehow maintain the state so that I can know how to update those values whenever I find a value which is greater than that. 73 is the first one, and then it comes to 74, and it's basically the next value itself, so I'm updating it with 1. Similarly with 74, 75, I'm updating it with 1, but for 75, it has to wait till it finds 76. So it has to skip through these values, but the data structure for this I can think of is using a stack or something, which would just keep track of all the previous records. If I basically keep on adding the values in a stack, which would basically wait for, hey, whenever the next value which is going to be added to the stack is basically greater than the top value in the stack, I know that I can simply remove that value and update the current value.
So basically he's describing the stack approach to doing the peaks and valley problem. So which this tells me that he's probably seen the problem before. or a variation of this. And so, as the interviewer, when I run into a situation like this, usually I'm thinking, okay, well, if the guy's seen the problem before, then there's not a lot I can do about that. But at the very least, he kind of knows his data structure and algorithm, so I'll probably give him a half pass on that. But if he's seen the problem before, then he better get this right. And so I would expect, as the interviewer from at this point, is that the guy is going to have a pretty clean execution and a pretty clean methodic code and an idea from here on out. If you go and rewatch what he did, he essentially just talks through his own algorithm. He doesn't make any effort to really check what he's doing or whether or not it works. Now, this is more or less a symptom of him having the idea already in his head. And in this situation, it can get very hit or miss. That is, you are pretty much all in on your solution because you've memorized it. Okay, so let's actually see what he did here. So yeah, he's gonna go with the array, and then he's gonna push elements onto the stack, while the elements are ascending, and then if the next element is descending, then he unwinds the stack and records the distance from each one of those. Overall, as a quick glance, I think his answer is right. His thinking is right. So this doesn't actually tell me anything about his engineering skills. So to me, I would treat this as if he had just, memorized the solution. I think it's fair for him to do this, but it's also a no signal from me. I can't really use this to actually evaluate the candidate.
So what about the cases like if the stack is not emptied, then
If the stack is not empty at the end, which is fine because we won't have any values which are to be updated in that case.
Wait, the interviewer does bring up a good point. Like, suppose that you end up with a descending order. Yeah, you will actually end up with zeros as well, because by default the array will be zeroed out. So there is no future temperature at which there is something higher.
so what about the cases like if the stack is not emptied, then
If the stack is not empty at the end, which is fine because we won't have any values which are to be updated in that case. So even if the stack is basically still populated, we don't have to do anything because we cannot update them because we haven't found a value which is greater than 76 or 73, and they would still remain 0.
So what I like about him, the candidate, is that he recovered very quickly. He understood what needed to be done. He addressed the actual issue itself. But again, the fact that he actually did it so quickly without actually going through an example, without testing it, this more or less supports the idea that he copy pasted this from his own memory because he didn't really run through an example. He didn't have to test it. He was so sure of himself. So I, as the interviewer, would be like, okay, well, at least he can think on his feet. But the fact of the matter is that here, I'm trying to test your engineering prowess, and all I see so far is a guy who has memorized a solution and kind of understands how that solution works. So, some points to him.
would you like to run this?
Sure. Let's see.
Okay, so what's he doing here? So basically he's describing how he's going to test all this scenarios. So he has the initial example that the interviewer gave him. Fine. And then you have the default empty array example. This is how you would also test it. I think that's a perfectly valid, acceptable case. Now he's testing the third one, which is a decreasing situation, which is essentially one of the branches that we have been dealing with, which is actually the primary core of the logic. So what we would expect is that all this to be 0. And then he just did the inverse, which is, okay, well, what if I just increased all of it? So we'll just test another branch of logic as well. And then the fifth one is just like if there is a constant numbers like a 72, 72, 72 right here, 75, 76, 76. I think these are perfectly reasonable. I think these do constitute a complete set of test coverage because you cover increasing, decreasing, a combination thereof in the first example, and then you handle like the bases and the branch logic here in the following examples. So I would say his testing is pretty good. I like what I've seen.
Can you explain the time can you discuss the time complexity and space complexity of this solution?
Yeah. So in this case, the time complexity is going to be So we are going to run through each and every temp value, and then we are going to also constantly remove the value from that stack. So we are running it for like a linear time, and then each and every value is going to be like popping it out from the stack as well. So this is basically like a linear runtime. So yeah, in this case, even though we are kind of like removing the values from the stack, but it kind of like depends upon the way the value in the stack is added, and we are also removing it constantly. So it is basically like a linear runtime, because we are just iterating over the loop and going over each and every value once. And the space complexity is also basically going to be like linear, because we have like a stack which is kind of keeping track of all the values inside it. So it's basically like a linear runtime and linear time complexity.
So the space complexity?
Oh, sorry. The space and time is what I'm talking about. The space is linear because we are using a stack, and also the time would be stacked because it's a monotonous stack, and we are kind of like using that to keep track of all the values, and we are just kind of like removing the values every time we find a value which is kind of like greater than that. So the runtime and also the space would be the same. So they both are like linear in this case.
Yeah.
Okay, yeah, I think that's right. He basically describes a linear time and linear space complexity. Just to recap for people who didn't quite hear it, you are iterating over every single element in the array, so that already lends itself to a linear runtime. Now, the reason why you use linear space is because every single element is more or less likely to be put into the stack at some point. And so the number of elements at which this stack grows, which is your auxiliary numbers with the auxiliary space, is also on order n. So that's what he described. I think that's correct. The one thing I will say is that when he's describing the runtime complexity, he's overly verbose. He just kind of described the same thing over and over and over again. So I think he just used way too many words than necessary. This is something I would definitely work on if I was him. You don't need to really do so much. You just really need to actually describe what the hell you're doing and why the runtime is the way it is. But he just he described it like 3 times essentially. That's kind of weird, something to work on, but it's small. It's a small nitpick. So overall, I think this one is going to be a pass from me. I might have a small eyebrow just because, oh wow, he memorized the solution, but the fact that he understands it gives him the points back if we're realistically speaking.
Do you want to, since we have more time, do you want to discuss another problem?
Yeah, sure.
So you need to find the median of 2 sorted lists.
Yeah, that's actually kind of an interesting problem. Off the top of my head, I would probably just run through the 2 sorted lists. I would just count every single element and then run through it again, and then keep a counter, and then whatever element is at the counter is going to be our element in question. Of course, this would involve looking at one list and another list, and then you compare the 2 elements, and whichever one is greater, then you advance that, or whichever one is less, you advance that pointer and increment the counter. That's basically the algorithm I would run with.
So when you say array, like there's a difference between this case. Are we talking about like a list or an array?
Array, sorry.
Okay. So I mean, I think I need to kind of like go with the same logic of finding a median for like one array and then trying to implement that for 2 arrays. So I mean, this is like a binary search problem where we can kind of like narrow down the search. Again, like the two different arrays can have values which are kind of like split in different ways. So we have to kind of like find a common kind of like a pivot where we can say that like, hey, these are the values which, I mean, kind of like using the same logic what we use for median with like a single array. We try to find like the middle value, and then we try to compare that with saying that like, hey, these are the values which are smaller than the median, or basically these are the values which are these are the values which are smaller than the middle value, and these are the values which are greater than that. And with 2 arrays, we have to still find that common value, which is going to give us all the values smaller than that and like all the values greater than that.
Okay, so basically what he described is doing a binary search across 2 sorted lists. Now, I'm surprised he came up with that off the top of his head, but again, I said at the beginning, he sounds like he's very well practiced. He's probably memorized and seen a lot of solutions and weird solutions to them. This one definitely is another one of those problems where that can apply. And so I'm curious to see how he actually executes on this because, to my knowledge, just being able to do that, the two sorted lists, well, there's a lot of caveats to that. For one, just because one list is sorted does not have any relationship on the elements of the other list as well. So I want to see how he executes on this.
5 and 6, if I have to find a median.
What are you trying to do? You're trying to find the median on first array and then try to find the median on the second one?
I'm basically like finding the median on the first one and the second one, and then I'm trying to compare like what would be what part of the array would I have to compare in this case. And I mean, I'm just considering one example here, like a smaller array, but like idea is to like check the like concatenate like two sub arrays. In this case, it would be the second part of it, and in this case, it would be the first half. So when we concatenate that, we were going to like narrow down the search only for this side, the second section, the second half of the array 1, and like the first half of array 2, and then we can keep on comparing it, saying that like, hey, like probably my median is going to be somewhere in the second half of array 1, or it could be in the first half of array 2, and then we keep on comparing the new median, which would be like, let's say there's like one more value between 2 and 5. We're going to compare that value with a median of 3 and 4. So we will notice that like in this case now array 2 has like a value which is smaller than 3 and 4. So we will basically like say that like now compare all the values which are in the second half of array 2 and like basically all the values which are in the first half of array 1. So this way we're just like reducing the number of search operations by just comparing it with median at a time. And this would all stop when we get to the point where we only have like one value to compare between them. And then we will say that like whatever the middle value is, now we are just going to like do now we like whatever the values that are left are basically like either it is going to be like one or two values, and based on that we can return whether that is the final median or not.
The idea sounds right from a very broad level stroke, but the details is what's going to make or break whether or not he solves this problem. I think that what he said made a lot of sense. What you end up doing, essentially, is splitting the array, both of these, and then, based on your number of elements, you would either look in the in each of the halves of the particular arrays. So, for instance, you look at, in this particular example, the median of what you're looking at is going to be 1, 2, 3, 4, 5, 6. So the median would be 3.5. Now the question is, how do you bring the elements closer to each other? And he said, oh, well, with some kind of logic, what's it called? If we had like these two pointers to represent the binary search window, we have some logic that allows us to bring this right pointer down into the top of array 1. But again, there is no correlation necessarily between array 1 and array 2.
Can you run your like each steps on this example? And yes.
So this would basically look something like this. If I am basically like splitting this based on like a middle value, so it basically would have like 1 which is going to be on the left section, and this like 3 and 4 which is going to be on the right section. Similarly, when I split this one, it would be 2. And then, so when I split, it's basically just like half of the size of the array, and like basically whatever. And since we are rounding it to the lower integer, like to the floor, so it will basically like add all the values which are greater than that to the next section. So it will look something like this. And now, based on the middle value, and now we have to just keep on comparing the values. Since A has I think let me see how it will look like when it's like an evenly sized array. So let me also change it according to if it is like a different size. But if it's like an even size array, it would basically like compare 3 and 5, and like based on that, it will pick like in this case, since 3 is smaller than 5, it will basically say that like, all the values which are smaller than 3. So basically like now so I can always maintain like a start and end. So in this case, the start initially was 0, and end in this case was 2. Similarly in this case, start and end was 0 and 2 as well. So like once we find this median, we are going to update the start to still remain as the start will now be 1, because we are going to look for values in the second half.
Once you do find the median, like what comparisons, what do you do to determine which half you need to check?
I'm just basically comparing the middle values and just using that as an input to
You compare 3 and 5, and since 3 is less than 5, you pick the right half for the first array and left for the second array?
Yeah, I mean, I'm considering, yeah, in this case, I'm considering that, and I'm also considering the size of the array being same. But if in case the size of the array are different, then I think it will vary. It will probably not be the same way I can do that in this case. The middle value.
Like when you divide, it should be like when you divide into two halves, like you are including median in both halves.
That's a good question. So I should not be including the median and both halves. So it should only be included in one of them. So in this case, if I'm comparing the values in this case, so 3 and 4 are, no, I think I don't need to include it in this one. So this can still be like start 0 and 0. This one would be,
Yeah, so basically this is the part where he's starting to get stuck. To me, again, because he has this idea and he's trying to figure out which way it works, but then it's like he hasn't really proven the route he's taken. I mean, it could be part of the whole, oh yeah, I'm just trying to explore if this answer is even viable or not. But to me, because he doesn't know exactly what his steps should look like or what his answer is in the end, he's kind of like, okay, well, maybe this, maybe that. In fact, the interviewer brings up a good point. Okay, he brings up that, hey, your indexes are going to be 1 and 2 or 0 and 1. This means that you're going to encapsulate the median of both these arrays, which kind of conflicts with what you had just said. So this is where he's at right now. It might be kind of hard to understand him because of like the noise and low quality audio, but to my knowledge, and at least the way I understand it, is that he wants to be able to select the left side or right side of each one of the arrays in which to shrink the binary search window. But he's running into some complications with this because it's not immediately clear how to do this.
I'm just getting confused because in this case now the array is of size 1, but like this 2 is not going to be relevant to us because now we have 3 plus 4 divided by 2, which is going to give me.
Okay, now he's acknowledging what his answer should be. So you notice here that he's been kind of meandering around and now he has given himself an objective to look at. So now he should have a little more focus, but he's already burned like 3-4 minutes just doing something that he could have actually done at the beginning. Say, hey, this is the answer to the actual problem that I have, you know. But not to harp on him, but I think one thing that you can actually learn from him is not just like to say what the answer you expect is, but also to define your stack trace, step through the problem piece by piece, and then define like the variable values. He's kind of doing it here with the start and end, and then stating what the halves of the array is. But I would like this to be a little more complete and a little more step by step. So
yeah, I think I'm kind of getting confused in this place. If I have, let's say, array of size 2 and 5, and if I do the same thing, it is going to like now be of like the median in this case would be size of 2. So it's going to be 3.5, and now it's basically going to compare all the values and say that like since 3.5 is greater than 3, it is still going to have all the values that are smaller than 3, like less than the median, which is going to be 2 in this case. So it is still going to be 0 and 0, and now here it is still going to be 3 and 4, so it is going to give me 3.5, whereas in this case it is going to only give me 2. So we cannot return 3.5 because that is not correct. It should return 3 in this case. So I have to still keep on comparing 3.5 with 2 and see that if it can be reduced to, yeah, I think this will now be reduced to 3, and since in this case it is reduced to 2, so it should not be reduced to 5. 3 and 4. Then,
Like, how did we reduce 3, 4 to 3?
So I mean, I didn't do like the median part here. So in case the median for this is 3.5, and we are going to look for the values which are going to be less than 3, because like in this case the median will be 2. So whenever the values are compared, we are going to consider the second half of it, and we are going to like consider the first, like the less than like the first half of it. So in this case, 3.5 value less than 3.5 is 3. So it's basically only going to have an array of input 3. And in this case, it is going to be, so I think this is when I'm kind of like confused, because if I've already considered 2 for getting the median, and now I cannot say that like it would not be like an empty list. It would still be and now we just compare the value which is bigger would be the one which is going to be returned back. And I think that's what I was trying to see if I can do that way to get like just one element from both the arrays, and then I can just compare them, and whichever is greater is basically going to is the one which I'm going to return back.
So that is the crux of his problem right there. If you didn't hear that, he basically said, hey, I assumed that I would have 2 medians of the array and that I could just compare the 2 and somehow spit out the answer from that. But again, the fundamental problem is that you're not guaranteed a relationship between the 2 arrays. So here, let's see how he recovers. But if I am the interviewer right here, I am already thinking, okay, this guy has obviously heard of the solution, and that supports what I saw in the first problem, where he's studied a lot, he's tried a lot of problems, and he's definitely seen a lot of LeetCode problems. But this right here is telling me that he's probably a meh engineer. Even though he knows the answer that he wants to head for, he doesn't actually take steps to actually set himself up for that. He actually just kind of hopes that the answer falls out of him actually doing the problem.
In this case, I could have even done with when I had like 1, 3, 5, 2, 5, 6, and even in this case, it could have been done in this space so that I can find if I find the median of this one, which is 3.5, and then if I I'm confused. If I have 3 and 4, then I get 3.5. This returns 3 here. And then if I compare 3 and 2, so this is going to return also that it returns 3 because 3 being the greater value.
So are you like, I'm kind of lost like how this is going to give you the results, because every time when you try to find the median on each list, you're reducing the size of each list by half, right?
Yeah.
So
basically, yeah. Right.
You are removing the elements by half. Does that mean what if there is 2 elements in the first array and 100 elements in the second array? For the first iteration, you will be left with 1 element in the first array and 50 elements in the second array.
Yeah. So yeah, I mean that's what I'm saying. So there's like slight difference between I was considering like 2 arrays of size, but I think when it comes to them being different, so it would basically be like going to compare the size of it. I think is whichever is greater. So we are going to so in case like so whichever element has greater length, so it would basically be looking to that. So yeah.
So if I'm the interviewer, the picture's already starting to become pretty clear. It's that he has memorized a lot of solutions. And in a lot of cases, he will be able to apply those solutions. But in the cases where he has maybe not that much confidence of whether or not the solution actually applies, he's not able to take the core fundamentals of the problem and apply them to a solution that he's previously thought of or seen. And that actually presents a really big problem. And in this particular example, I think he got to where he is simply because he saw a problem like that, threw out the solution that he memorized, and then kind of hoped that the solution would fall out instead of actually logically working through the problem and saying, hey, because of this step or because of this fact, we need this condition. Going back to what I said about the list having no relationships, if he actually just drew it out step by step, he would have realized that shrinking the binary search window involved simply just looking at the intervals marked by the borders that he wanted. What I mean by this is that if you said your first window began at one point in the first array and your second window began at the second point, and so since you know what the median is because you can count all the elements in the array, you can find that particular number. In this particular case, it's going to be 3 and 4. So all you have to do is just look at where the median is between these two borders and then advance it based on the number of elements on each side of the bar. So I think if he had just logically considered that, he would get to an answer. But he didn't do that, so this tells me he over-relies on memorizing. If I had to give my final assessment as an interviewer, and I think this is probably what he will say, let's see later on, is that this guy knows what he's doing in the sense that he understands LeetCode problems. There's no doubt about it. What he doesn't do is follow proper engineering and problem-solving strategies. Instead, he just kind of like going for a shoot and pray. And you can kind of see his lack of objective here with his where he doesn't actually come up with the answer that he's looking for. He actually comes up with an example, but then he doesn't know the answer to that example, and he just kind of hopes the answer falls out of it because he's seen something like this before. So his communication is good, his problem solving is fine, but his I would not hire him. This would just be a no hire for me, simply because he's not able to set himself up for the right success. He didn't logically go through and follow the problem, try to solve it. He didn't really do any of that. And I felt like a lot of his headache could actually have just been solved if he had just taken the proper precautions, such as knowing what answer he was looking for, just taking a step back and maybe thought about, okay, well, if you're not looking at medians, what else are you looking at? Well, again, if you're doing a binary search, you have the binary search window. So which means that you need to be able to figure out the size of that binary search window, which should have led him pretty close to the solution. So that just kind of falls out of a logic of having just, doing proper problem solving. So that is why that's why I don't think this guy would be a pass in my book. And for that reason, I'm out.
For the feedback, I have like the initial solution what you provided, like for the first problem, it was really good. Like you asked relevant questions and before jumping into solution, and you come up with a straight away optimal solution, and the code is flawless. Let's see. And I really like the implementation and everything is neat. I think you are already familiar with Stack, I assume, and straight away picking the right data structure is a good thing. And coming back to the second question, I'm not sure, like, have you heard of this question or similar question?
I have heard of it, but I think I was just kind of like approaching it in a very different direction. So like I said, I was just kind of like not following the question properly. But I think I've heard of it, but I've never solved this question. I definitely feel like this is a very important question to practice. So I will definitely look into it.
Yeah, one suggestion I could give you on that one is try to, before trying to figure out an approach, like try to run your kind of solution with different inputs so that you can see, like, once you think you got a solution, try to come up with an examples where you can break it.
Got it.
Yeah, see, I think the interviewer just takes what I said one step further. So yeah, it's basically what I said, except he takes it one step forward. Instead of just knowing what the answer is to your example, also try to break your own algorithm. once you have an idea of something, then just try to find counterexamples that might actually break it and make it fall. So I think that's also a pretty good lesson for anyone who is watching this, that you should not only be able to test the happy cases, but also all the edge cases as well. And you could hear him also give the feedback about the optimizations, where you would actually just do a binary search on a small, array, and before you do the large array, whatever that optimal answer might entail. But regardless, it's important to really think about these things.
That would help you you spend a lot of time here trying to make your approach work, but try to see is there any test case which can break this?
Right.
Yeah, that would help you to eliminate any approach you are taking. Maybe it may not work or something like that. But apart from that, I really like your problem solving, and I really like your coding style.
Okay, so let's actually see what the feedback is here. My guess is that he's gonna give him some pretty good scores for like the communication and stuff, but it's gonna be like a no pass. So let's actually see what the feedback is. Feedback, advances person to the next round. No, that we kind of expected that. He got 3 out of 4 on the technical skills portion because he understood what a stack was. He studied LeetCode and he knows how to code. That much is very apparent. The points off were because of his inability to really dissect a problem, and that's also somewhat reflected in his problem solving ability, where he didn't state his answer to his example, and his ability to really just understand what needed to be done for that second problem. That really is what killed him. So I would have actually put, I would say probably 2 out of 4 for me, or even less if I'm feeling like I have a bad mood that day. But I think this is a somewhat generous score. Communication ability is good. I think that anyone who is watching this, if you want to learn how to communicate, I think this guy does a pretty good job at that. But that's also because he has a solid idea, at least in the beginning, of what he wanted to do. So that's what made the communication so much easier. Now let's actually see what the feedback for the interviewer is. I think the interviewer was actually very fair. I think that he was able to actually communicate and adjust the candidate. I mean, so would he want to work with this person? No. Why? The interviewer was fine. I didn't see any particular reason why you wouldn't want to work with him. I think the interviewer did a good job poking holes at the candidate's code and all of that good stuff. How excited would you be to work with them? Okay, he didn't answer that. How good were the questions? 3 out of 4. I think that the question was pretty fair. I think I can understand why he said 3 out of 4, but the hard problem is probably what pissed him off. I think that asking a hard problem that we don't expect the candidate to code up is perfectly valid. So I disagree with this assessment. I think it's 4 out of 4 actually. And it's pretty close to what you might expect actually at a top tier tech company coding interview. Now, how helpful was your interviewer in guiding your solution? I think it's pretty good. He was definitely spot checking, trying to adjust you, trying to make sure that you knew what you were doing. So I think this is just salt. This 3 out of 4 is just the dude being salty. But but overall, my final thoughts, I think this was a pretty good interview. I think there's a lot to learn. I think even for people who feel like, hey, I'm the man, I got this, I know every single answer. Well, obviously this guy thought he did know every single answer as well. But turns out when you come across a problem that you've never seen before, your real engineering and problem solving ability comes out. And what we saw today was not that. So with that said, guys, thanks for watching. Hopefully you guys learned something from this. Hopefully this helps you improve at your own interviews as well. If you want some coaching support for your upcoming interview or just want some career advice or consultation, you can book me for interview or career coaching at echantech.com. If you like this video, please like and subscribe, and I'll see you all in the next one.